The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people were evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. Still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, my group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
This is live.
As we go through
Still
this,
lava
we're growing
moving.
closer
They weren't
together.
just sharing
Community. When tragedies like this strike, you really realize how much you need each other.
Aloha everyone, I am geologist Philip Ong here with Mr. Dane DuPont of HawaiiTracker.com, bringing you guys another Kilauea and Maunaloa volcano update today, Thursday, September 23rd, 2021. There's not a whole lot going on the volcanoes, to be honest. We're going to just catch up on monitoring signals and do a quick throwback, and then we'll discuss some of the viewer questions that you guys have. So pass them on to Dane, who will be answering whatever he can in the chat and collecting some questions for us to discuss a little later on, as well as monitoring our stream. So let him know if you have any issues with our audio or our video, and he will pass it on to me as I narrate today's update. And I thought today we'd start out with this view here out of the HVO observation tower, the old observation tower, still at Wikahuna on top of Kilauea. This is looking here to the south at the main Kilauea caldera, and you see that the roof of the old volcano observatory building down here. And so this is Kilauea Iki right in here with the Pu'upua'i cinder cone from its lava fountain that's shot in here, way up here like this. You see a little bit of this lava shield. Kilauea's lava shield, the high point of the old volcano before the caldera collapse, was over here. We'll pan it around over here. You can see Maunaloa in a distance back here, and then the edge of this down drop block where the scientists have been mapping all the gas is all down in here, this area all right in here. Right? And that's still higher up than that deepest part of the pit, which we'll keep scrolling here to the east, and it's just that you can't quite see it in the reflection and shadow, but at that deepest pit's right in there. So there is another camera. There it is. That's pointed out the other window. So here it is, looking at that bottom of that window. Kilauea, a little distorted here on the left, but there's Maunaloa's shield once again. And there is our deeper pit coming in right here, and it will be down in there that crusted lava body is still sitting cooling, as it will be for a long time. And panning around, you see a little bit of the old signs right in here of the old Jagger Museum, the Uekahuna Bluff. It's all closed to the public now due to earthquake damage from 2018 collapse. And it's in the area over here that we've had all those web cameras and instruments that were looking down into that pit, right? So when we saw these views, it'll pop it up again. Views like this of what our current pit with lava lake that's crusted over. There's still liquid lava underneath that crust, what that looks like today. And it'll probably be disrupted by something that happens in the future, but so far there's no signs of that actually happening. Our recent intrusion event was further off, kind of off in this direction over here, like more over there, and at the edge of our image over here. And all underground, of course, and not directly connected to this. So it was a slight reprieve. And the long-term pattern is that Kilauea has resumed its pattern from before with some slight adjustments, some nuances we'll look at here shortly. But to continue our pan around over here, this is now looking back across the parking lot, where there's a vehicle parked going to look at Uekahuna. And you see the flank of Maunaloa. This is that southwest flank over here, the sun setting behind it, some clouds glowing over there. And clear views to Maunaloa Summit today. And there's Maunaloa Summit. It's also quiet, and you see we'll pan it all the way around. You can see the rest of the view as it's captured on a web camera. It continues off further this direction beyond the view of the camera, obviously. So Maunaloa is there on the other side. This is one of the magic of the spot, being surrounded by the volcanoes and on both sides of you, to your north Maunaloa, to your south Kilauea caldera. So we're going to switch things up today and look at Maunaloa's signals first, but we'll start off by looking at the earthquakes. This here is the USGS earthquakes monitoring page from their website. And for the last week, and all I've done here is color it by depth. So let's see if I can get this key to pop up here. Oh, nope. There we go. So here we have it by depth. The deeper purples here, greater than 40, and then the shallow stuff essentially is a red, but the blues and purples are deep and the reds are shallower. So the pattern we have on an island in the past week is we still have our deep earthquakes around Pahala region and a little bit of a cluster halfway to Loihi. It's all interesting, but really neither here nor there. Nothing really alarming or changing about that. There's some unusual events. There's some deeper ones in this area that's south of Kilauea's caldera that may be part of its pathway, perhaps. Some version of a pathway either from there or somehow that comes to the shallow parts of Kilauea. You see there was a deep one underneath Hilo Bay that happened not that long ago. Perhaps it'll let me highlight it here. Let's see if it does. No, spinning circle. And a deep one under Mauna Kea. Well, I'll wait for that to catch up perhaps over here. So, you have to let's try to close something here. It's not responsive on my screen here. But Kilauea, you see there's a pattern of a few earthquakes right around the summit region. Oh, there, popped it up now. 2.4 near Hilo Bay, depth of 47 kilometers. That's over 30 miles down. So these are adjustments of that whole island stack of giant pile of volcanoes above that tectonic crust of the ocean plate, and it's just deforming and adjusting as it shifts over that zone of heat of the hotspot that's down here in the southeastern part of the island. Let's see, I'm having a little bit of a response issue with my station here, so let's see if I can do something to correct that.
Yeah, that thing's not really responding so well, is it?
Yeah, let's see. I'm gonna close that restream, and looks like it's all right, and maybe it'll monitor itself. All right. So yeah, that's our earthquake pattern. Let me point out a couple of these other ones here. Mauna Kea, 2.4, 26 kilometers. There's a second one under there that's 1.9, 20 kilometers. Nope, I don't need more information. Okay, thank you. There's a deeper one here in between Maunaloa and Kilauea. That's interesting as well. That's perhaps another adjustment to the shifting balance through there. And you do see a few on Maunaloa Summit area as well. So we haven't seen quite as many on Maunaloa Summit, but there are a few starting to pick up. There's not a whole lot in general, but there's more than we've seen recently, marginally. And Kilauea is relatively quiet with that summit and south flank pattern still ongoing here for the past week. So that's our general pattern. There's another deeper one here offshore, 2.6. So these are all about magnitude 2s or so. If I look at Mauna Loa's, this one over here is at 5.6 kilometers, 2.3. There over here to the northwest is 1.9. To the northeast, it's 1.8. To the southwest, we have a 2.1. So a couple of them in the magnitude 2 range there. That perhaps we haven't seen as much of that recently, but only a couple. Nothing really major going on. It's just a very marginal change, and at this point, we've been looking at it under a microscope, so that's the only thing we have to point out. Mauna Loa's update here, not erupting, issued today. Rates of seismicity are still slightly above long-term background levels, they say. Have not changed significantly over the past week. Other streams show no significant changes. That's the summary there. 88 earthquakes this past week, all below magnitude 3.0, right? Sometimes we've seen this be below 2.5, so you can see that there might have been slightly larger during the past week is what we're seeing here. And 88 is just a slight increase. Last week it was 66, week before that it was 60, the week before that it was 58. So it was, it's been holding fairly steady, but a little increase from 60 to 90 or so. Still not a huge amount. Everything else here noted as normal. So earthquake rates in Mauna Loa over the last year, you can see we're still in this range over here, less than 100. That's basically nothing compared to the events we had back in early April and in March as well, late February to March. Not to mention, even going back to last year, October last year and December last year, January last year, even those levels are higher than now. So we're still relatively low, even though it's coming up marginally. It's still not anything to write home about. Here's a little more resolution over the past month. Earthquakes per day now, the last one was per week. And so we're reaching levels of 12, maybe up to 18 earthquakes per day, but not a whole lot more than that. And if we look at the cumulative moment, it's this red line on here. We don't look at that very often, but that tracks a little bit more rather than raw numbers. It tracks a bigger earthquake. So if you have magnitude 3, it might cause a jump like that, right? This might be magnitude 1.5, this might be magnitude 2, that kind of thing. So when you see a lot of these jumps, it tells you you're getting bigger earthquakes. And so that's the little bit of the pattern you see here. You see a little bit more jumping up and down rather than a flat rise like you've seen more so in the last week. So you see a little bit of a change in pattern there, but still very, very low. That's the microscope we can put Mauna Loa under right there. If we look at the map view of the last month, you can see here it's a little more populated. And you can see there's certainly clusters of events in the northwest, to the southwest, and over here to the east, more dispersed and smaller. Nothing like we saw before, where you couldn't even see the shape of the caldera. Everything was covered in dots, but it is slightly up. And looking here at the last week, it's looking a little more lively than before as well, but really not a whole lot there, to be quite honest. So moving on, our GPS over the last year. Here it is. The long-term pattern is pretty flat. You can see here's the adjustment we had back in February to March to April, all through there, right? And back to October last year when we started having somewhat of this adjustment up and down. And you can see that the levels that we had back at that point are more or less what we're at now. So not a whole lot of net change even from a year ago, even though we had quite a lot of variation in between here. So really not a whole lot of change in Mauna Loa, and if we were to zoom in and try to microanalyze here, maybe we can see there's a trend going up, but it's done this kind of thing before, and as long as it stays within this range of wiggle that it's been doing, I have to see it probably rise above that and keep going to believe it actually be a real trend. So it's still within the noise is how I would see it myself right now, considering what we've seen for the last 6 months or so. So that's Mauna Loa, and we'll switch right over to Kilauea. And Kilauea earthquakes over the last week look like this on the automatic USGS map. Still down here in Pahala. Here's those 2 deep ones we talked about before, about how that deep conduit may come up in this direction. So we won't rehash that today, but that's not unexpected to have those there. Sometimes you see them more even in the area over here. So it's a little bit further offshore, in fact, right? But maybe that's related. And in the shallow system, you see earthquakes right around the summit, that inner summit depressed pit, right? More so inside of that collapse zone than outside of it, which is really low level, but interesting to see that being the case as well. Really nothing in the East Rift connector / Upper East Rift zone, nothing in the Southwest Rift at all. A couple background events over here in the Kauai region and some in the East Rift zone. We actually weren't seeing any of this East Rift zone stuff last week, so we might be having a little bit of adjustment happening in there. We'll look at that here shortly. But mostly the south flank keeps going on as if nothing going on elsewhere is affecting it. It's pretty much oblivious. It just keeps moving along and doing its adjustment regardless of what else is going on in the volcano, apparently at this point in time. And that's not unprecedented. That's done that in the past, so no surprise there. That's the last week. And let's iterate here. Here's our earthquake rates and depth for the past month. So the earthquakes per day, once again. A month ago, we're in the middle of that seismic crisis, the intrusion in the Southwest Rift. That's what you see over here. That was reaching up over 200 earthquakes per day. And so in relative comparison, since we're scaled to see that, our earthquakes now, you can see here in a range of, this is a 50 per day mark right there. So it's hovering slightly above 50, slightly below 50, around 50 or so. And, maybe it's hard to really see any trend in there with that kind of scale, but essentially still fairly low. You do see there, we did have a larger, you can see one of these larger jumps happen. Slightly bigger earthquake, but nothing massive. We're still only up to 1.4 times 10 and 22 here, which meaningless unless I bring it up to you guys more and more often. You might see one a big earthquake, how much this thing actually jumps. All right, so that's the past month rates. Here's what the past month map looks like. So we're still catching that intrusionary pulse about a month ago, as it spread and expanded to also include the Southwest Rift as well as that summit area right there. And the South Flank it's just still doing its own thing, and of course Pahala is still doing its own thing as well. So contributing quite a few earthquakes. If I scroll down here to the cross, let's see, does this one have a cross section? No. Quite a few earthquakes between the small ones that are shallower above it and the deeper ones below, the blue ones being the deeper ones here. Okay. Kilauea earthquake rates over the past year. So here we are. Our most recent earthquakes per week is around 200 or so, and which is, if you were somewhere else in the world, that might seem like a lot, but for Kilauea, it's not a lot. Our earthquakes per week peaked out at 1,200 during our intrusion crisis week over there. And it had been around a background of around 600 or so, right? Maybe 400 to 600 within that range right in there. You can see that we appear to be at the low end of that, if not below that currently. So we still haven't popped back up. We haven't remained at background like we did before during intrusion pulse last year. That's not what we're seeing here. We're seeing a ramp down, and we'll wait till it does something else, right? So for now, everything seems to be a downshift. It's basically one idea that's consistent with this would be that intrusion essentially rearranged the blocks on that south edge of the volcano there, and it's allowed more pathways to open, and so there's more space to put the lava, the magma, and fill without having to actually swell the volcano and cause all the earthquakes. So the magma is still coming in, don't get me wrong. It's just not stressing it and bulging it the way it was before because of that adjustment that occurred about a month ago during that intrusion. That upper southwest rift, perhaps, and definitely that South Caldera region. So we'll look at a little more at that here shortly, but let's cover our bases. Here's the gas. There's another measurement that was taken within the last couple of days here, and popping in right at 60 tons per day. 60, 55 or so, 60 before that. We had one that was up at 110, which is still within that background range. And interesting that it was slightly anomalously higher. Not exactly coincident, right? Kind of delayed after that intrusionary pulse that occurred more or less through here. That's the pulse dates more or less, and then afterwards you see that little higher gas measurement, and then back down to what it's been pretty consistent actually. over the last 3 measurements here. And our ambient measurements, nothing alarming there. We're really not going to see anything on this lowest station until this calibration spike scrolls off here. But nothing alarming in the gas as well. So looking at the tilt next, here's a tilt at Uikahuna over the last month. And the scale of microradians is positive 10 at the top, negative 6 at the bottom. That's a 16 microradian range. That's pretty decent. So now we're not looking at decimal points, so that's actually a measurable change there. And you can see that perhaps prior to, maybe we'll call it the 3rd or so, September 3rd or so, maybe, but prior to that, it would look a little more flattish. Even during that intrusionary pulse, that was essentially from the 23rd to the 30th. Right, that's the intrusionary pulse time. So maybe the 31st or maybe the 3rd, depending on, you know, somewhere in there was the start of that inflationary trend, which has been what we've seen up until just the last 24, 36 hours or so, where it seems to have flattened out a little bit. And now maybe perhaps some small inflation style signals coming through. But overall, the pattern for most of the last week and the week before that has been this inflationary trend at that Uikahuna site. Right, that's the one that's closer to that shallow Hale-Maumau chamber area. So if we go back to the one that's closer to the intrusion site, its scale of microradians here is going from positive 20 to negative 80. That's 100. That's a huge scale. And it's still catching the intrusionary deformation here, where really this green line was really pushed off quite a bit, right? So quite a lot of deformation that happened in this case to the southeast of the Sand Hill station, and that's what this green line refers to. Whereas a blue line refers more to that Hale-Maumau direction, like the Uikahuna tilt we just saw. So there was some nuance happening in there, but essentially from this point on, you can see from the 31st, maybe the 3rd, somewhere in there, you see this inflationary trend on the blue line coming up, and it's rising fairly steadily, right? If we actually look at the range of it, we're, I don't know, maybe a quarter of the way up above that tick mark and a quarter of the way below it, so maybe we're halfway, 10 microradians or so on the Sand Hill station of tilt inflation from the Hale-Maumau direction. And interesting, at the same time, you see that after that inflationary pulse to the southeast in that dike area, presumed dike area, that after it stays more or less flat, then around the 6th or so, you start to see it deflate. And it's coming down from halfway up to that bar to the bottom, so it's also deflating in a range of, our tick marks here are 20 microradians, so also 10 microradians or so. Right, so interesting that the dike area is deflating while the Hale-Maumau area is inflating now. Hale-Maumau area is always see on a Uikahuna plot. And so that's interesting to see. So back to the USGS main deformation page and try to see if we can hone in this a little bit more. Here is the zoom into the last 2 days. Our scale is from positive 0.4 to minus 0.3. That's less than 1 microradian range. So this is all minor, tiny signals compared to what we're just looking at. Barely worth noting what the wiggles might be. Whereas looking at the last week, you see here's that little wiggles we're just zoomed in on, and an inflationary trend of the last week mostly until really the evening of the 21st. It seems to flatten out a bit. And zoomed out for the past month, that's what we were just looking at. That there was that last couple days, and then prior 2 weeks, and then intrusionary phase right there. So that's our tilt pattern, and let's see what the GPS shows us across Kilauea Summit, north and south. This little deviation was an intrusionary pulse right through there. And it looks like we are still spreading from north to south, right? And we're actually seem to be doing that at perhaps a steeper, higher rate than we had earlier, right? Almost like it's trying to catch back up to this previous mark here. So we'll see. That's interesting to see that it seems to be in certain directions a little bit sped up, and we'll try to analyze this a little bit more before we wrap it up here. But just to note first, over at Pu'okone, our scale there is quite a lot smaller. But we had noted previously that the reports from USGS of backflow from the East Rift into the summit area during that eruption might have been expressed through this signal over here, contraction across the East Rift zone by Pu'o. And a similar pattern seemed to be beginning but within very small nuance of change here, seems to maybe be adjusting in slightly opposite direction here. So more about the sign rather than the magnitude of change here, and we can look at whether that's a real thing or not, and perhaps time will pass and we'll just see it resume its previous trend. So it's possible to analyze these things too much, but that's what we are doing, just to try to gain any insight and put out hypotheses that could be proven incorrect or correct, either way. All right. So, 2-year GPS, I might look at this a little bit different. I know it's probably hard to see the details. These are 2 years, left to right, and we have east, north, and up components. So, there actually are 4 stations around the summit that I've put here in the northwest in the top left, on the east in the top right, in the southeast in the bottom right, and the southwest in the bottom left. The intrusion happened over here by the outlet in the bottom left. So you can see that looking at the up signal, it went up quite a bit, and it seems to have actually not be rising anymore. Right? And similarly in the southeast, it went up quite a bit and is not rising anymore. You see that station had been moving to the south. It's not, and now moving to the south faster. Crater Rim had been moving to the south, and now moving to the south faster. And as far as moving to the east, it's still moving to the east at a similar rate in the east. However, well, perhaps if I zoom in on it, that's really hard. Yeah, it's hard to tell. It's a similar rate there to there. It might be slightly slower. Maybe you could call that flat. It's not enough data quite there yet, but maybe it's slowed down. And if so, it may be related to the fact that here further to the west, at the outlet, you see that ever since that intrusionary pulse pushed it really far to the east, it's since been tracking back to the west and has not stopped moving. It's still adjusting back to the west, which is consistent with a deflation of that dike area there. Whereas looking at other components there, we saw that's not the case. It seems to have resumed its previous trend, although really it's not moving up as well. So there's there seems to be still some adjustment happening locally to the outlet site. As far as Wikuhuna to the northwest, you don't see much nuance in the north or Byron's Ledge either. You don't really see any change in the up. It seems like it's really not changed anything. So really still rising in the north, but no longer rising in the south. Right? And the south is moving south faster, and the north is kind of moving north at the same rate as far as we can tell as before. So really it's about the south part of the caldera that's doing the moving to accommodate what's going on. And so that gives us an idea of what's going on and where that filling underground may be happening, even if it's doing so without the seismicity. And the adjustment seems to be happening in that southern part of the caldera a little asymmetrically, and that's not unusual. We have seen that before, but that's interesting to see there. If we scroll down to our East Rift stations here, we talked about this a little bit. There's not a whole lot of change that's evident, but if anything, you may see that. There is a little change in the last couple of weeks here at the end of these graphs, which maybe is if you were to go way out in a limb, you might say maybe there is some expression of maybe the magma is trying to work its way back in that rift zone area once again, and that's what's causing these wiggles back and forth. But we really don't have nearly enough data to really suppose that. It's just interesting to imagine what those signals might be there. Okay, so that is the GPS, and just to perhaps reassure you guys, there's nothing going on down in the lower East Rift Zone once again here. This is a time that perhaps, as we'll discuss shortly, may be triggering certain people, as there is in the news volcanoes affecting people's livelihoods right now. But to wrap up Kilauea, here is the source of our information: USGS weekly update from the USGS Hawaiian Volcano Observatory. And this one issued on Tuesday a couple of days ago, and they say it's not erupting. Our codes for both volcanoes are still advisory and aviation yellow, and they say, following the intrusion of magma beneath the surface in the area south of Kilauea caldera, which slowed substantially on August 30th, earthquake rates and ground formation in this area have remained near pre-intrusion levels. Other data streams, including SO2 emission rates and webcam views, showed no significant changes. So that is the story there, right? 25 earthquakes in that region, no seismic activity, tilt meters have detected no substantial deformation, supply of magma to the intrusion has stopped. These observations suggest that the supply of new magma to the intrusion has stopped. And SO2 at a low rate. Maunaloa observations. The surface of the rate is actively erupting from 2020 and 21, is covered by stagnant solidified lava crust. No indications of resumption of eruptions. There's a little slight change here since we mentioned this last week on East Rift Zone observations. No unusual activity reported in Kilauea East Rift Zone. However, this is a new sentence. Ground information motion suggests that refilling of the upper East Rift Zone between a summit and Pu'o may have slowed slightly since the recent August intrusion. SO2 and hydrogen sulfide emissions from Pu'o were below detection levels 9 months ago. So I still object a little bit to that 9 months measurement being referred to here still. But the key thing here, perhaps significantly slowed refilling of that rift zone. That's really all we have for Pu'o there. I'm going to do a quick throwback today to 100 years ago. This is September 20th, 1921. A picture taken by Thomas Jagger. Right, as we talked about, we've recently, it's probably been a few months now, we talked about the overflow of lava in March 1921 when we did our last 100 years ago segment, and a much more extensive one. It was a lot more activity then, right? But the lava had receded back down into the pit. There was still a lake and still all these crags that are changing shape and distribution. But it was really August and September that they came back up to the point where you see here, this is the rim of the crater in the background, and you can see that the crags are actually above the rim of eye level here. That was a notable thing for Jagger to document there at the time. So a couple follow-ups real quick. Here's a graph from 1921 of lava level. It's hard for you guys to read, but this is the rim of the pit. The black bars are the height of the lava. As you can see that early in the year, it actually came above the pit and spilled over. That was March. Had come back down and came back up and didn't quite reach the edge of the pit there. But these open white bars, that is the height of the crags above it. So the crags actually came above the rim of the pit. One more time, right around this time in September, October, 100 years ago. And you can see that that was one of the last times that happened. In fact, this whole era of crags doesn't last forever. It only lasts into 1922 and a little bit tailing off to 24. But really, the era of crags is almost over 100 years ago, with one last emergence here above the rim here. Of course, we'll as we continue our 100 years series, once in a while popping in to see what happens, we'll check into 22 and 23 and all that as time goes on as well. So. But that's the appearance of it and the map. You can get a little better idea of it. The white stuff here is active lava ponds, and they call it lava bench, this darker stuff, and the crags are these towers that are sticking up here and here and here and in the middle of this central lake, right? Several ponds and coves, and the whole thing like a piston above that pressurized chamber below. So interesting to think back about how these configurations actually changed. Changed in relation to pressure in a volcano. For example, 100 years ago, they actually, as people today watch the equinoxes and declare that the equinox had something to do with this high stand, but of course, in the end, it didn't work out so cleanly. It actually began several days before the equinox and lasted for about a week afterwards. With a secondary pulse that came through a week afterwards, not unlike our intrusion, perhaps, extrapolating a little bit as far as rising rates of the whole epic magma and all that. But longer pulses that actually, would push this whole piston upwards and move all the crags and then settle back down again. And we don't have this open indicator, we'll call it, right? Indicator, like in this big bubble level of lava features to reveal the pressure within the volcano. We just have the tilt meters instead. But perhaps, someday, if that magma within that crusted over pond gets hard and sticky enough, it might start forming some interesting features as the ground below it starts deforming and result to some of these events. And so interesting to consider that as we consider other events around the world as well. This week's Volcano Watch goes back to the 2017-2018 Vanuatu Eruption, and so you can go check that out on hawaiitracker.com. But talking about a volcano that has a lot larger groundwater contribution and leading to phreatic and phreatomagmatic eruptions with more explosives, and so looking at explosions and what can be learned from that. So irrelevant, as here is a NASA image of Ambai Island in northern Vanuatu here, and some signals from seismic records and audio records of explosion pulses coming out of that volcano, enough to the point where they had to evacuate the whole island, as seen in this image here from August 21st, 2018. There is a claim in here that the 2018 eruption on an island of Hawaii received global attention. The Ambai eruption had a larger global impact due to the huge amount of gas released. So that's interesting to note there. There was a huge amount of gas in our 2018 eruption as well. So for them to say that there was even more gas from Ambai is definitely intriguing and provoking there. So we'll perhaps can look up that number someday and get back to you guys on that. But so as we focus elsewhere on lessons learned, I really have to mention.
Are they saying there that the emission rates were higher than Kilauea in 2018, or they just had more of an impact because of the proximity and trade lanes?
The sentence says, while the 2018 eruption in the island of Hawaii received global attention, the Ambai eruption had a larger global impact due to the huge amount of gas released.
Right.
And
it'd be interesting to see the emission rates.
Right. And the thing that in particular was, if we want to dig into it maybe slightly more, when the gas was released from these eruptions, it was putting out ash as well into the atmosphere. And so that did affect aviation patterns. And so perhaps that's what they're referring to. But they do mention earlier there was an effect on aircraft flight patterns there. So perhaps that's what they're getting at. But yeah, just point out, as we know, there was a huge amount of gas that broke all the instruments that they can even measure it properly at the time. Out of Kilauea, so not happening now, but interesting as well, right? And of course, we want to prepare by studying areas like that for any possible situation in Hawaii that might resemble that, with eruptions near water, whether it's by the ocean or through shallow groundwater or what have you. So that's why these kind of studies are done. Why we look at places like Ambai, why we look at 100 years ago on Kilauea. And of course, there's a lot of science happening all the time, but I do want to turn our thoughts and prayers to the Canary Islands today. And I want to point out that this is the Twitter page of INVOLCAN, which is the Institute, Canary Islands Volcanology Institute. That's the official science branch there, and there's a lot going on. There are, from what I found, the webpage is not updated as often as Twitter. So if you're interested in finding out what's going on in Canary Islands, you can scroll their page there, or Diablo. And you can see high fountains building a huge cinder cone already. There are some ash-rich phases. The lava is basaltic, apparently, but apparently more gas-rich, or more, slightly more explosive in some ways than what we've seen recently in Hawaii. And of course, I'll blow this one up here. This is why this is something I wanted to talk about in slightly more detail, even though I'm not always so eager to talk about other volcanoes and focus on Hawaii only. But you can see here that this eruption site is coming right through the populated areas here. And so it's a situation that we're very familiar with, and we sympathize with, and definitely know what that's like, and really feel for the residents of Canary Islands there, La Palma. So just wanted to give that shout out here. And I think that's interesting. If you scroll through their feed here, you can see that they're having issue with news media wrongly interpreting their statements, right? Someone said, "Oh, there's been a deflationary pulse came through," and they're like, "Oh, that means the magma is withdrawing; it's going to end." And that's not at all what they meant. They had to go and try to discredit that false state. So the same interesting, those kind of things happen, and you see people talking about having to combat not just the situation of the hazard of the volcano, but also the misinformation that's going on as well. So that's a large part of why we do what we do here, and why we still reflect on our 2018 experience and try to rehash and even though it's painful sometimes, to be able to reflect and learn lessons from that, right? Because clearly it's relevant if we're going to see lava coming through civilized inhabited areas like this more and more often as more people are living in areas where this happens in the world here. So I'll wrap it up there, Dane, and make sure we thank Hawaii Tracker. HawaiiTracker.com has a lot of local information here, and I'll pass it over to you here.
Yeah, just a few more things about the eruption in the Canary Islands. The incredible thing that I was seeing was the height of the fountain. It was I was hearing reports of 1,000 meters, which is just huge. Like I was looking at Pu'u'o, and it was half that at its height. Iki was only 300 and something meters.
580.
So just a 580.
580 was the record. Okay. Kilo Iki, yeah.
Right. So yeah, roughly half. It's just a huge fountain. They're also running basically snowplows to push all the ash out of the streets that's been collecting around the town. So the dust masks and stuff like that is important. We had similar with the Tephra. I remember guys, sweeping the streets of the Tephra after the eruption. So yeah, it's really heavy stuff for them to be going through.
Yeah.
We'll get into some thank yous. We are brought to you by HawaiiTracker.com. Check out HawaiiTracker.com for all of our latest information that we're dropping in chronological order there, so it's easy to find. We are brought to you by the viewers, basically, the viewers like you that help support this stream either by liking, subscribing, sharing the video, or maybe considering to make monetary donations on HawaiiTracker.com/support. And we appreciate everybody here. We also are supported by a few businesses. First is Kilauea's Kilauea's Bar and Grill in the heart of Pahoa. And they just announced their secondary establishment in Orchid Land. So they're going to be expanding with a new menu there. So we really appreciate them and look forward to seeing their new establishment once it finally opens in early October. And they are the old establishment in Pahoa is still open, indoor, outdoor dining. They got a full bar, so if you're in around Pahoa, definitely check them out. The second supporter is Kalani Tours out of Kona, and they offer a few different types of tours, one volcano tour, some waterfall tours, and also a Kona coffee farm tour. They do the smaller, more personalized groups, so you can get to know a little bit more about the area and some of the history about it, as opposed to the big tour bus style tours where it's somebody basically yelling at you over an intercom. So it's really where we would recommend to check out if you're looking for a tour coming to the island, and we appreciate them as a sponsor as well. We also are brought to you by a grant by the Hawaii Community Foundation, the Puna Strong grant. We appreciate their support as well. So with that, we have a little bit of a few questions here, not many, to look at. The first one is from Richard, who asks, will all the data prior to the next eruption match up with the readings prior to the previous eruptions?
There's a big range of kinds of signals you can get. So it'll match up with something we've seen before because we've been watching this for a long time. But most often we see a pattern of building up earthquakes, building up the GPS spreading rate, those kind of things before anything actually pops out. But there are times where you do have small eruptions occur without the earthquakes and without a whole lot of pre-monetary information. So can go both ways, and that kind of makes it. I mean, the answer is yes, because both things have happened before, but it doesn't exactly tell us how it's going to go the next time, which is, I imagine, what you're actually getting at. So we still have to just wait and see, as usual. That's how it works with this volcano, and it's the one series that nature is writing that we just have to wait and see what the next chapter is. We don't know when the next release date's going to be. It's TBD.
Yeah, it reminds me of the quote, history doesn't always repeat, but it sure does rhyme. Kind of that type of thing. Next question is from Freeman, who asks, how far does the island move per year off of the hot spot with the drift?
To the northwest. I don't remember the rate exactly. It's I want to say 4.5 inches a year or something like that.
Yeah, Google's saying roughly 4.
Roughly 4.
Just, roughly 4.
Yeah.
So, I mean, that's, in terms of geologic movement, that's quite fast.
Yeah, that's of all the plate motions in the world, I think the Pacific has it's in the faster end of it. Yeah, I mean, there are some that move not that much. Can't really move that much, right? Imagine like Antarctica is totally surrounded by spreading zones, and so is Africa. It's hard for them to really truck along, right? Whereas one that's got a kind of more of a conveyor belt style where it gets subducted, like the Pacific Plate does at its northwest. The Pacific Plate's the biggest one, so that means that the oldest end of it is relatively older, which makes it slightly denser and perhaps a little heavier. So that can pull it down, and maybe that's one idea of how you could get it to go faster. To really get into the details there of it. And it varies across the whole Pacific Plate, and here on the island Hawaii, to kind of bring it back, it's 4.5 inches a year, something like that.
Yeah, I was just looking up. Somebody in chat, Richard, mentioned that it's moving about as fast as your fingernails.
Yeah, that's an analogy we often use. Grow. Yeah, about as fast as your fingernails grow. Yeah.
All right. Well, that really does it for our questions. There is going to be another episode of Drones On premiering after this, looking at June 22nd through 29th of the 2018 Kilauea eruption. We talked about some algae blooms, an experience I had on the backside of Fissure 8 that was unpleasant, and we get some very up-close footage of one of those lava rafts making its way down the lava channel. So definitely check that out. It's roughly 10 minutes, and it will be here after this live stream.
All right, mahalo Dane, mahalo everyone who contributed, asking questions, interacting in the chat, financially, mahalo you guys, all of our sponsors, and everyone who's liking, sharing, and subscribing. And right after this video is over, before our Drones On comes up, that's a great time to do that. We appreciate it if you do. And if you really want to go warrior for us, go find someone on YouTube saying something stupid and send them to some real information.
And pass me the reference on Twitter. GeoGolf Hawaii. I always enjoy looking at those.
There's apparently no shortage, unfortunately. So once again, just that maybe worst thing one last time. The reason we're doing all this is to build our community resilience, so we can be prepared for a next eruption in the future. So we have, when we're faced with something like Canary Islands is faced with today, like we will face on our island again, certainly someday, that we can have more people that know what's going on and can explain and focus on the actual actions that can help in the short term, right? Having a knowledge of the patterns and the hazards and the signals and the sources of information and all of that gets wrapped into it. And so mahalo everyone, and we will be back with you guys next week unless there's a reason to come back to you sooner. Until then, aloha for Dane DuPont and Philip Ong.